deviation is a topic that is not in the mainstream math courses within high school. I believe standard deviations can only be taught / learned in data management. It's also, it's similar to calculus, but it's on, the statistics side. So, if you're in mainstream math, you might not be aware of this topic. But this is something that would be testing your SAT. So we're going to go over what is it and how do you solve for questions that are relating around standard deviation. Keep in mind that there is, so for standard deviation, when you're trying to solve for actual values, actual numbers, there is formulas to go behind standard deviation. And, if you're interested, you can absolutely search it up. It's not the shortest, but within your SAT questions, they will not be asking you to solve for any standard deviation numbers. What they're asking you is for your understanding of what standard deviation is. So with the questions that you'll be seeing right now, I'm gonna give you sample questions, but before going over what this topic means, and you'll see that you're not actually asked to calculate what is the standard deviation, right? Like within a set of data, you might be asked to calculate mean, median, and mode. That's not the case with this. So let's get into this. Okay, here we go. All right, so first things first, standard deviation. Who has heard of this term before? Just by a raise of hand. Okay, so we're all familiar with that. Okay, great. So recap, standard deviation is it measures the spread of a data distribution. The more spread out the data distribution is, the greater its standard deviation, right? Now, in this case, when you have a comparison of between two different data, and I'll share my screen for this. When you're looking at a set of data that has, they are, let's say, they are a questionnaire for two different classes, the green class and the blue class, based on same questions that you're asking. However, you're getting totally different results, right? Now, the standard deviation is measuring how spread out a piece of data is. So therefore, you want to notice what is if there is a more centered kind of graph, and sometimes you can graph these as you have a distribution that would have a curve, it looks like a curve that's going on top of your graph like so. And that is the method that you can be comparing your data. So when you're seeing the green graph, you can see that the sides where 0, 1, and 9 and 10 are, when you're basing on these numbers, there's not a lot of numbers. Actually, there are no numbers. And however, when you're looking and more focusing on the middle component, you can see that where 4 and 5 are, they have the most amount of entries, right? So just by looking at the graph like so, you can determine that when you're comparing the two graphs, the graph that is the blue on the very bottom, it has even, you can even think of it as a range, right? The range of the data spreads far more than the range of data in the green section. So therefore, your standard deviation, with calculation, this is going to be 2.79, and the green is going to be 1.59. Right? So that is to understand what standard, what it is. And something to remember as well is standard deviation cannot be negative. A standard deviation close to 0 indicates that the data point tends to be close to the mean. So there was a dotted line at the graph that I just showed you. I'll show you again in a second. So the further the data points are from the mean, the greater the standard deviation. Because the standard deviation is calculated from the mean, it's calculated from the middle point. So going back to our graph here, we can see the mean, where is your, for both is going to be different for both the green and blue data set. And yeah, the dotted line is where you would consider your standard deviation to go from, right? And the further you go from that mean, that means, or if your standard deviation is a high number, it means it is the space going from that middle value. Okay, and just to just to give you a really like a solid understanding of what this is, I'll give you an example. Okay, a really quick example, just so that you can understand it with no problem coming into any questions that might have this topic. When you're talking about standard deviation, when you're talking about the distribution of your data set, right? Now, the way of how standard deviation works is when you have a graph, a data that looks like so, and let's say you have another data that is a lot more narrow, the standard deviation actually calculates the amount of data that you have, one standard deviation, two standard deviation, or three standard deviation away from the mean. Now, what I mean by this is I'm going to put down the same dotted line as we had in our graph. And from this dotted line, we are going to see what is the difference between a small SD and a larger one. Now, comparing these two, you'll see that the top graph is a lot more spread out than the bottom. And what happens here is that when you have a standard deviation of this graph, what it does is so whatever the standard deviation number is, you can use that number to go one standard deviation away from this midpoint right here, right? So this is actually one SD away, and this is also one SD away. Now, obviously, for this bottom graph right over here, it's going to be different because it's more narrow and your number is going to be smaller. So let's say because at the top, your SD was this wide, this amount away from the mean, for the bottom graph, it's going to be a lot closer because the smaller the standard deviation, the more narrow your graph, right? The more kind of clustered together your graph is. So in this case, my standard deviation might be here, right? So this will be one SD away and then one SD away. Funny enough, what SD is there is, obviously you're saying one standard deviation, one standard deviation, but understand that there is a connection between these two graphs. And that happens when you're considering what is the total amount of data that is under the one standard deviation range. And what that does for us is that kind of unifies, or that kind of connects, right, standard deviation to standard deviation for different graphs. Like, why do we care about this? Because, obviously, standard deviation, how does it relate from one graph to the other? It matters because the standard deviation actually, the one standard deviation tells us that there are 68% of data that is within this range. Okay, so within that range, and that kind of makes that, that is the connector, and that is what unifies standard deviation from different graphs, because one standard deviation for all graphs, all data sets, gives us this information that 68% of our data will be below this curve and will be within this range, right? And the same thing and it makes sense because for the bottom graph, your graph is going to be taller, and obviously the data it's growing vertically, so it doesn't have a lot of room to go in its width. However, it can go vertically because it grows that way, and it takes up more room that way, right? Like growing up. And same thing with two standard deviation as well. So when you have two standard deviation away, so this is 2 SD, and let's say your 2 SD for this bottom graph is going to be here. Same thing, but recognize that the spacing between 1 SD to 2 SD, they're the same, right? So whatever your standard deviation is, that is this, you go from the same spacing from the red dotted line to 1 standard deviation to 2 standard deviation. And for 2 standard deviation, even though my graph does not seem like it, some of them, but it accounts for 95% of the data. So this is 95, right? So this data over here, and this is 95.